Hi, this is Mr. McConley, and this is BKW General Physics. And what we're going to talk about today is power. Now, we've been talking about flow rate, electrical flow rate, those electrons flowing through a circuit, and we're just going to take it one step further. We're going to combine something we learned about in the past, electrical force, and just to remind you what you learned back then, electrical force was voltage. It was the push of those electrons. So we did electrical force, voltage, earlier in the year. More recently, we've done electrical flow rate, and the electrical flow rate we called current. And we did this for series and parallel circuits recently. Now, electrical rate, current, is given the letter I. And as you recall from a while ago, force, voltage, is given a V. Potential, voltage, potential to push, to do work. So let's switch it up to power now. Power, when you say, oh, that's really powerful, power means it's the rate at which you're doing the work. So, it's not that you are really strong, that's really your force, but if you can do work quickly, you're very powerful. This most simple definition, power is work divided by time. We talked about a little bit when we were doing our work chapter, W, work. It's work divided by time, how quickly. But for electrical, that's really where we want to focus our attention today, because that's the chapter we're in. We're in electrical. Electrical power can be written three different ways. Let me start down here on the furthest one. I hope you can see this in the video. Power is voltage squared over resistance. So, you know what voltage is. You can measure that with a voltmeter. It's in volts, 110 volts squared. But resistance is something you might not be as familiar with. Resistance is the resistance to the flow of electrons. So how easily they can pass through a wire. So there's a way to measure this with an ohm meter, or there's ways to calculate it also. But this equation is one way to figure out power. Another way to figure out power is this one. This one has the current squared times that resistance. Again, you got to know the resistance, and then if you get the current, which we recently talked about here in red, then you could put that in there and you can figure out the power. But the most useful one for today is really going to be this one. Power can also be the current, which would be in amps, and the voltage, which would be measured in volts. If you were to be able to measure the current and the voltage, you could figure out the power of something, electrically speaking. And both of these things are pretty easy to do because we learned that you can use an ammeter when measuring current, and you can use a voltmeter. I was going to write voltage again, I don't have an eraser. Voltmeter to measure the voltage. So if you times those two together, you can get the power. Now, that's the basis of what I'm going to show you today. Over here, you will see that I have a device. Let me turn this a little bit further. I have a device called a wattmeter. Now this wattmeter, I'm just making sure that the camera can see what my field of view is. All right, that works. What this wattmeter really does here is it's doing exactly the two things we talked about. It's measuring the current and the voltage, combining those and telling you how much watts a specific device is using. So right now I'm using my 42-inch TV screen here. And by the way, this is turned off. It's totally off right now, but it is plugged in. Here's the wire from the TV, it's plugged into the wattmeter, and the wattmeter is plugged into the wall outlet. So right now when a TV is off, you can still see that there's a standby light on. Sometimes you can even hear a little bit of a humming sound. And so, I mean, is it using any electricity? Well, let's check and see. So right now, this TV in its off position is using about 25 watts. Now that number is going down because I think it's because when I plugged it in, it had to kind of like boot up some capacitors and get some settings and some memory things. So it's usually like 25 watts, like a 25 watt light bulb. Now this thing actually measures in kilowatts, but we know that kilo means just move the decimal place over 3 places, so 25 watts. All right, so let's see what happens if we were to turn this thing on. Somewhere back here there should be a power button, wouldn't you think? Yeah, there we go. I don't know where my remote is. So when I turn this thing on, it jumps from 25 to now it's at 78 watts, 79. I don't know that it's actually going to get any channels. So what would happen though is if the picture screen came up right now, because right now it's just, I don't know what setting it's on. It's probably set for, let's say, to have a DVD player hooked into it or something. But if this screen turned on and we turned the volume right up, I would bet we could get this up over 100 watts. So this TV was using 25 watts off, and now it's at 79 watts, which it's on, but it's still not really all the way on because it doesn't have the screen or the sound going on. So, kind of interesting. Let's compare it to something else. Back here I have one other thing that we can check. Just gonna grab the camera here. Walk with me, like you have a choice. So, gotta boost this up a little because I'm kind of tall here. Let me see. Yeah, that should get me. So I have this old-fashioned projector, and this old-fashioned overhead projector uses a big light bulb that gets really hot. So I have the feeling, or I have the thought, that this might use quite a bit of electricity. I'll point it away so we don't shine the light right into the camera. So when this is turned off, we can take a look at it, and it really does have 0 watts. It's not drawing any current or any voltage, it's just off. It's not computerized, so it's not running anything, it's just off. But when I turn it on, let's see what this electricity jumps to. So this is 575 kilowatts, or that's 0.575 kilowatts, or 575 watts. 575 watts. You know, that's like, you know, a 100-watt light bulb's a lot of electricity. This is 575 watts. And what I'm noticing is that as it gets hotter, because this bulb starts warming up, and it's running a fan and everything, this number is slowly creeping up as it warms up. And I suppose it will do that. I don't know how far it'll creep up, but it will keep creeping up. So what we've learned about today is that power is based on current and is based on voltage. If you know those two things, the push, which we call the force in the beginning of the year, the push, and then the flow rate, the current, if you know those two things, you can figure out the power for an electrical device. So for today, this is Mr. McConley, BKW, General Physics.